Okay, 7.5 day 1, we're going to talk about a binomial distribution. We're really going to be looking at continuous functions. Discrete. Make sure you have a calculator. I'm going to show you how to do some stuff in the calculator towards the end. So make sure that you have one handy. So there are a few common types of discrete probability distributions. One of the most important that you should know is called the binomial distribution. So we're going to talk about binomial today, and then we'll do geometric tomorrow. So properties of a binomial experiment. First of all, there should be a fixed number of observations, or trials as we call them. So n is always going to be the number of trials. Number 2, there are only 2 outcomes for each trial, either success or failure. 3, the outcomes of the different trials are independent. And 4, the probability of success, P, should be the same for all trials. So when you have a binomial random variable, X is usually defined as the number of successes observed within the fixed number of trials. So let me write that out. X is the number of successes observed within the fixed number of trials. Now, back up to number 4, the probability of success P is the same for all trials. You'll see pi in the book, just so you know, they use pi. Okay, so are the following considered binomial? If no, why not? So from past records, it is known that 5% of all electronic calculators manufactured by a certain company will need major repairs within 3 months. Your company has just purchased 10 calculators. Let X be the number of these calculators which will require major repairs within 3 months. So this is binomial. So like 0.5 would be our P. That would be our probability of success. We have 10 calculators, that's our N. And they either need major repairs or they don't. Let X be the number of tosses of a fair coin before the first head is observed. This is not binomial. There's not a fixed number of trials. We will talk about that tomorrow. Past experience indicates that 1% of mass-marketed paperback books contain at least one production error. A bookstore has just purchased 1,500 copies of a recently released paperback. Let X be the number of these paperbacks which contain at least one production error. So again, this is yes, it is binomial. This is your P. This is your N. So I'm going to kind of go through the process of like what we used to do in Chapter 6 versus now what we're going to do in Chapter 7. So some of this is going to be a little bit of a repeat. You've probably done these before, but I'm going to kind of lead you into what we were trying to do with Chapter 7. So past studies have shown that 20% of all surgical patients who receive a particular type of anesthesia experience mild post-operative nausea. Suppose that 3 patients are scheduled to receive this type of anesthesia today. Draw a tree diagram to identify the 8 possible outcomes and their probabilities. So what we would normally do in Chapter 6 is we'd have patient number 1, nausea, no nausea. That'd be 0.2, 0.8. Then from there we'd have patient 2, nausea, no nausea. So again, 0.2, 0.8, 0.2, 0.8. And then we'd have a third outcome. Nausea, no. Nausea, no. Nausea, no. Nausea, no. So 0.2, 0.8, 0.2, 0.8, 0.2, 0.8, 0.2, 0.8. So if I want to find the probability of each one, I'd have to multiply each part of the tree diagram. So like 0.2, 0.2, 0.2, 0.008, 0.2, 0.2, 0.8, 0.032, 0.2, 0.8, 0.2, 0.32, 0.2, 0.8, 0.8, 0.128, 0.032, 0.128, 0.128, 0.512. So there's already 8 outcomes. There's the probability of each. So on the next page, what we're going to do is we're going to create a probability distribution for the number of patients. So I'm going to use these. That's why I started with them. So you'd have X, you'd have P of X. So you could either have 0 patients experience the nausea, 1, 2, or 3. So for 0, it's really easy. It's just the one at the bottom, 0.512. 3 was the first one, 0.008. And then 1 and 2 are the combinations of adding 0.032, 0.032, 0.032, all 3 of these, and then 128, 128, 128. Because there's 3 ways for each one of those to happen. So when you add them up, 0.384, 0.096. So what's the probability that 2 of the 3 patients have postoperative nausea? So X equals 2, 0.096. So is there an easier way to do this? Yes. So this is where the Chapter 7 stuff comes in. You've done Chapter 6. That's what you would have done in the past. Now we're going to do Chapter 7. So the probability will start with 0. X equals 0. We're going to do combinations. So there's 3 people, combination 0 have the nausea. And the probability you get nausea, or you don't get it, is 0.8 cubed. So then you end up with 0.512. Now to do 3C0 in a calculator, you can hit 3, then go to math, probability, 0. It ends up being 1. So it's 1 times 0.8 cubed. There's our 0.512. The probability X equals 1 will be 3C1, 0.8 squared, 0.2, because there's 2 people who didn't have it, 1 person that did. 3C1 is just 3, because remember there are 3 ways for that to happen. And then you end up with your 0.382. Probability X equals 2 is 3C2, 0.8, 0.2 squared. Again, 3C2 is just like there's 3 things, we want a combination of 2 of them. It equals 3, because there was 3 ways for that to happen. 0.096. And then the probability X equals 3 would be 3C3, 0.2 cubed, which is 0.008. And 3C3 is just 1, just like 3C0. And you have 3 things and you want 3 things. So for binomial distribution, where n is the number of trials and k is the number of successes, here is the formula. So it's nck times p to the k power 1 minus p to the n minus k power. Now your formula sheet has it written differently. They write n over k with parentheses. It's like a mathematical way to write the combination. pk times 1 minus p to the n minus k power. So this one is on the formula sheet. And it's, so looking at what we've been doing in Chapter 7, we were on this row for 7.4, now we're on this row. So here's our x equals little x, n over x. They use x instead of k. But so there's your formula. So suppose I roll the die 4 times and x be the number of 6s. Find the probability distribution in x and the probability to get 2 or more 6s. So we're going to have x P of X. So 0, 1, 2, 3, 4. Okay. So the probability I get 0 sixes would be 4C0 times, now really it's going to be 1/6, I want 0 sixes, so it's going to be 1/6 to the 0 power and then 5/6 to the 4th power, because anything to the 0 power, remember, is just 0, or just 1, and this is just 1. So I'm really only doing 5/6 to the 4th power for this first one. So we're going to say 0.4823. So 0.4823. Probability x equals 1 that I have, I should put x equals, sorry. So 4C1, 1/6 to the 1st, 5/6 to the 3rd. 4C1 there is just 4. And then if I put that in the calculator, I get 0.3858. Probability x equals 2 equals 4C2, 1/6 squared, 5/6 squared. So do you see sort of the pattern emerging, hopefully? 0.1157. And this is actually just 6. If you remember from Algebra 2, Pascal's triangle, that's what you're doing. That's what this row is. Probability x equals 3 is 4C3, 1/6 cubed, 5/6 again to the 1st. This is just 4th. So 0.0154, I'll fill these in. And then the probability x equals 4 is 4C4, 1/6 to the 4th. And again, if you want to put 5/6 to the 0, I wouldn't mark it down if you didn't. But now you can sort of see the pattern, 0.0008. So before, like in 7172, I told you to wait till 2 to the end, because you wouldn't be, we didn't talk about Pascal's triangle and all that stuff. But now you can do anything on your own. So do you see the pattern? It goes 0, 1, 2, 3, 4, and then 4, 3, 2, 1, 0. And then each one of those increases. So what's the probability x is greater than or equal to 2? I get 2 or more 6s, 0.1157, 0.0154, 0.0008. So 0.1319. So that obviously does take some time. So there's actually an even easier way for you to do this instead of using the formula, and that's to use your calculator. So in the calculator, you're going to go to the distribution menu. So you hit second vars, and there's your distribution menu, and you're going to go down to where it says binomial PDF, binomial CDF. So binomial PDF, n comma p comma k, is the probability there will be k successes and n number of trials. So it's a probability, PDF stands for the probability density function. I think PDF is equal to a point. So I think p point. So this is the probability that if it's binomial in 5 trials with a 15% probability, I make one of the shots or whatever. So the only thing you're going to need to remember when you're doing the calculator, you have to label the calculator talk. So this is the number of trials. This is your p-value. And this is the number of successes. If you do not label, you will get marked down. Every time you do not label, you will get marked down. So in the AP exam, they'll give you half credit if you do not label. So in the calculator, I'm going to go to binomial PDF. Now, mine is an updated operating system, so I can put trials 0.151. If you have an 83 or not an updated operating system, type it in exactly as you see it on the paper with the commas and the parentheses. So then you hit paste. So the probability that I'll make one shot is 0.3915. So that's the same as doing 5C1, 0.15 to the first, 0.85 to the fourth. Okay? Now, I don't necessarily always use the calculator when I'm doing a single. I use it more for cumulative. So the probability, when you have CDF, binomial CDF, that gives a number of successes less than or equal to K. So this is asking that I get less than or equal to 1, so either 0 or 1. Same thing though, you have to make sure you label. So this is the number of trials. This is P, number of successes. So now this is cumulative. So it's in the same section. You go to second vars, binomial CDF, and again 5 trials, 0.15 probability, X value is 1. But if you look, you get a higher number because it's including 0. So 0.83521. So this is including, this is the probability that at most 1 successes, so 0 and 1. So CDF stands for cumulative. So a lot of people will ask, what's the difference between PDF and CDF? PDF is for a point, CDF is for cumulative, so for less than or equal to. We'll talk about greater than right now. So if I roll a die 30 times, what's the probability I get at least 5 sixes? So, probability I get at least 5 sixes, X would be greater than or equal to 5, at least 5. You may want to make sure you write this out. It's part of showing your work. And I like to write it out personally because it makes, it organizes everything in my brain. So now here's the problem. I can't do greater than in the calculator. And I don't think you want to do 5, 6, 7, 8, 9, 10, 11, 12, all the way to 30 and add them all up. So we're going to use the complement. I'm going to do 1 minus the probability X is less than or equal to 4. Now here's where you need to be careful. This took me a long time to figure out. Sometimes I write it off to the side. I'm thinking, okay, remember, this is a table. So I have 1, 2, 3, 4, 5, 6, 7, 8, all the way to 30. If this was a table, each one of these would have a probability. So I'm thinking, I want the probability of 5 or more. Well, I can't do that. So I'm going to do 1 minus, 0 should be in there, 0, 1 through 4. So that's why I'm including 4. That's the cutoff. There's nothing in between 4 and 5. So it's okay to go down a number. So I'm going to do 1 minus binomial CDF. So I have 30. The probability I get a 6 is 1/6. And I want 4. So again, I need to make sure I label. Number of trials. P. Number of successes. So if I do that in the calculator, uh, 30, 1/6, 4, 0.4243, and you can do 1 minus the answer if you want. So 0.5757. Okay. So now let's talk about mean and standard deviation when you have a binomial variable. So the mean of the distribution is just n times p. That'll tell you where the mean is of the distribution, no matter what the distribution is. Standard deviation is n times p times 1 minus p. Again, these are on your formula sheet. And I really like the way the new formula sheet is. Again, it's just a single row. So binomial, mean, standard deviation. This was discrete we did in 7.4. mean, standard deviation. We'll get to geometric tomorrow, mean and standard deviation. So this whole table is chapter 7. Okay, let's try a couple more examples, just so you can understand it. Sorry, these notes are kind of long. Suppose that 75% of all customers at a gas station choose 87 octane gas. If you observe the next 50 customers, how many customers would you expect to choose 87 octane gas? So again, this is the expected value. It's just like the mean. So mu of x would equal 50 times 0.75. So we would expect 37.5 customers. And you know this is binomial. Again, 50 is your n. This is your p-value. What's the standard deviation? So sigma x would equal square root 50.75.25, and you get 3.062. What's the probability at least 80% of the customers choose 87 octane gas? So again, at least 80% of 50 is 40. So x is greater than or equal to 40. So just like the one before, I can't do greater than. So I'm going to do 1 minus the probability x is less than or equal to 39. So that's 1 minus binom CDF 50.75 39. So number of trials, P, number of successes. Again, make sure you label every time, because I have had students in the past not label and they get marked off 1 point each time. Trust me, you do not want that to happen. And you can do the whole thing in your calculator like I am this time. I already did the 1 minus, just because I happen to. So my answer is 0.2622. I did the one, you can see the 1 minus at the top. What's the probability that the number of customers who choose 87 octane gas is within 2 standard deviations of the mean? Okay, it's kind of a hard question. So I'm going to take 37.5, I'm going to subtract 2 standard deviations, and I'm going to take 37.5, I'm going to add 2 standard deviations. So for this, I get 31.376 and 43.624. Okay, so now we need to come up with numbers, because remember, in this situation, our tables are only whole numbers. So I think of a number line. I have 31, 32, all the way to like 42, 43, 44. So I want within these 2 standard deviations. So I want in between 31 and 32 to in between 43 and 44. So I'm really finding the probability from 32 less than x less than or equal to 43. So I'm finding it from 32 to 43. Hopefully that makes sense. I'm a visual person, so this makes more sense to me if I look at it this way. Now, again, cumulative is only less than. So I'm going to find the probability x is less than or equal to 43. So I'm going to take 43 and below, and I'm going to subtract the probability x is less than or equal to 31. So that'll get rid of all this stuff. So I'm going to go 43 and less. I'm going to subtract 31 and less. Again, remember, there's really nothing in between 31 and 32. So I'm going to do binom CDF 50.7543, number of trials, P, number of successes, and I'm going to subtract binom CDF 50.7531. The biggest mistake people will make is they don't go down a number when they're doing this. Or they go up a number when they shouldn't. So, if I put that in the calculator, I get 0.9806 minus 0.0287, so 0.9519. So about 95% chance that I have between 32 to 43 customers who choose that octane gas. So this was a lot, one of our longer lessons. So make sure you kind of go back. Again, this stuff you're not going to need to know. Kind of really start from the second page. The second page front and back is really the more important stuff to look over. Make sure you understand. But you'll have some time. We'll do a day in class where we'll just work on 7.5. So you'll have some time to work on this before a quiz or a test.